Assalamu alaikum. Hi guys. Today I'm going to continue with the bond anchorage and development length. Today actually what we are going to do is show you how we extend the reinforcement at certain sections where we can cut off some of it. As you know, there are certain instances where I don't need the full reinforcement. So at maximum moment, maybe I have 525, for instance. I don't need the 525 obviously for the whole beam. I only require maybe 2 or 3 of them at certain sections with lower moments. So here I'm going to show you how we are going to do that. So what are my critical sections? My critical sections are obviously the point of maximum stress, or say maximum moment, points where tension bars within the span are terminated or bent. Again, at locations where I do not require the additional reinforcement, the faces of the support, points of inflection, and by that I mean where the moment changes from positive to negative, again, which is a location of zero moment technically. So to do that, I'm going to start off with this drawing right here. So here what I'm having, this is part of a continuous system. This is the center line of this beam right here. Here is column number 1, and then I have, and then it repeats itself in this direction. Here I have my negative moment, which is near to the column, and here is my positive moment. So reinforcement here is going to be in the bottom of the beam as indicated over here, and the reinforcement here is going to be at the top as indicated over here. So now I'm going to introduce you to the sections that I have. So section number 4 is at the center line, and it resembles for me the maximum moment, maximum positive moment. Section 5, and I have 2 bars, a blue bar and a red bar, okay? And both of them are needed at section 4. At section 5 here, I'm going to decide to actually discontinue the blue bar, but keep the red bars going on. Section 6 is a point of what we call an inflection point, where the size is changing from positive to negative. At section 1, this is at the face of the column, and usually close to the maximum negative moment. Again, I have 2 bars, this dark red and this green bar. Section 2 is the section where I no longer require both the green and the dark red bar, so I'm going to have this continued. Section number 3 is actually where I no longer need the negative moment at all. So let's start with the provisions, and so at least you get an idea of what we have. So first of all, I'm going to start with section 1 for the negative bars right here. So at section 1, I'm going to need both bars. So for that, x1 need to develop, I need the development length. And by the way, the development length here must be in this direction and in this direction as well. Okay, so development at point 1 needs to be in both directions. And for that, this distance, I'm going to call x1, has to be larger than LD. Okay, so for the negative moment, all I need both of these bars to have the development length. So this is the easy part. Now, what happens at section 2? At section 2, I no longer require the red bars, and I want to discontinue them. So for me to discontinue them at section 2, then I have to give them an additional length of distance x2, which is going to be the larger of D or 12 dB, but the green bars also must develop the development length, and this is x1 by the way, and this also should be more than LD. Okay, So now the green bars technically are going to have the development length at section 1, and then you're going to have another development length for section 2. To make it closer to you, think of it, if this is my cross section here, and I have 4, just using numbers here, 4, 5, 525 for instance. Okay, so these 4 are at section 1, which must develop the development length. Okay, now if I want to discontinue these 2, meaning I do not want these 2 anymore, and these 2 are these one right here, then after the section that they are no longer required, which is section 2, I have to extend them either D or 12 dB. Right, now the remaining 2, these 2, must now develop the development length for them to be fully yielded. Okay, so that's for section 1 and section 2. Now let's move to section 3, and let me concentrate on again, now I'm talking about the top green bars. So at section 3, if I want to discontinue that green bars, then after section 3 I need to develop a length of the larger of D, 12 dB or 1/16 the clear span. So the clear span obviously is the distance from face to face of the column. So whichever is larger, that's the length that I'm going to need beyond section 3. So now if you look at this drawing, so let's assume, and I'm talking only about the green bars here, so let's assume that the development length I calculated to be 1.4 meters. So that's my development length. And let's assume that the distance between section 2 and section 3 is only 1 meters. Okay, and let's assume that for x3 that D is the dominant part and D is equal to 0.4. all right, so now since the distance between section 2 and section 3 is 1 meter, then I'm going to need the additional 0.4 meters, right? So after section 3 I'm only going to need 0.4, but since I already have my development length as 1.4 meters, then I don't need to add this D, okay, because it is contained within my development length. But if my D is equal to, let's say, 0.5 meters, okay, then now this 0.4 obviously is not going to be enough. Then I'm going to have to add 1/10 of a meter. So then the total length here that would extend from section 2 would be now 1.5 meter, which is again more than my development length. So the moral of this story here is, if my D, 12 dB or 1/16 is contained within my development length, that is fine. If not, then I have to just extend it a little bit. This is one school of thought. Another school of thought says no, just add D, 12 dB or 1/16 clear of span on top of the development length regardless. So the choice is completely yours, but according to the ACI code, if it's contained within, then you can just leave it as is. Okay. So that will take me now to the critical positive moment. Now the positive moment actually is a little bit more, it has more provisions, because some of the bars will end in a tension zone, and I will explain. Well, first of all, you notice that for usually the negative moment area, this is always usually smaller, and the drop in the moment is always sharper than the positive moment. Here you can see in this area how it takes more for the maximum moment to dissipate. Here it takes it a lot less to dissipate. So now let's start with number 4. Again, number 4, here it's the same as section 1 for the negative moment. I need to develop that length. Again, I have 2 bars, and let me change the color to green. I have the red bars and the blue bars. Again, both of them need to develop development length in both direction. So this here also need to have an LD as well. So it's just to be larger than LD. So now again, this is at section 4 where I need both these bars. Think of it like I did before with the 4 525. I would like to have 2 constant and extend the other 2. What I failed to mention in the negative part is I need to at least have 1/3 of area steel continuous. So now going to section 5. In section 5 is where I no longer need the blue bars. Then I also have to extend them D or 12 dB. Okay. But again, the remaining bar obviously need to develop my LD. But here, what's happening here is when I discontinue these bars, they are still going to be in the tension zone. So if these bars are still in the tension zone, then I have to fulfill these conditions. Okay, so I'm gonna go them by condition 1. So here it says it shall not be terminated in a tension zone unless A, B, or C is satisfied. So what is A? A is that the V ultimate is less than or equal to 1/3 phi Vn at the cutoff point. So where is my cutoff point? This is here my cutoff point. So at this point right here, I have to calculate V ultimate, okay? And I also have to calculate phi Vn, which is what? Which is phi Vc plus phi Vs. So we calculate Vc, whether it's equation A or equation B, or to be more specific, which is whatever equation you used in your shear design, plus phi Vs. Then 2/3 of this must be larger than the calculated V ultimate, which is coming from the load. If that happens, then I can discontinue my blue bars at that location right here. Okay. If this is not satisfied, then I have to go to B. So for phi 36 and smaller, continuing reinforcement provides double the area required for flexure at the cutoff point, and V ultimate is less than 3/4 phi Vn. So here's still at this section right here again, okay, I have to calculate V ultimate, and I have to calculate phi Vn, which is the same, but now instead of being 2/3, now it's be 3/4. But the caveat that M or provided is double M needed. Okay, so if the provided area of if the provided is double the needed, then you can do it. If not, then section B doesn't hold. Then we have to go to condition C. For condition C, the stirrup or hoop area in excess of that required for shear and torsion is provided along each terminated bar or wire over a distance 3/4 D from the termination point. So going back again to this section right here, we're still talking about this section. Okay, so what he's saying here, at this terminated point, I have to ignore whatever stirrups I have from shear or torsion, and I have to add more stirrups in this direction. That distance is about 3/4 of D, and that spacing shall be at least 0.41 B web FYT, and this is one of the, if you remember, one of the maximum spacing that we have during shear. So this is how we this is the spacing that we have to provide over this distance right there, and that distance shall not exceed the diameter of 8 beta B. Beta B is the ratio of the reinforcement cutoff to total area of tension reinforcement at the section. So let's say I have 4 phi 25 and I'm cutting off 2, then that area would be 1/2. Okay. because it's 2/4. So now I have to calculate the spacing from two equations. This is equation number 1, and this is equation number 2. So you can see there's too many provisions for the cutoff at the tension point. And that's one of the reasons why, from a practical perspective, nobody cuts it at the tension point. Okay, unless it's far. But again, if you can justify all these three, then you can cut off at this point here. So that takes care of that. Moving on now to section 6. Section 6 is what we call a deflection point, and that's where it changes from positive to negative or 0. The caveat with this, obviously this can be done at simple supports and point of deflection. The diameter bar for positive moment tension should be limited to such that L for reinforcement satisfies A or B. So this is A and this is B. Now A says that the development length should be less than 1.3 mn, which is the nominal moment at section 6, divided by V ultimate also at section 6, plus what we call LA, and LA is either D or 12 dB. The reason why we have MN, and we talked about that at the beginning, we've told you that the bond stress is actually related or proportional to the shear, and was also proportional to the change of moment divided by the X, if you remember, or by L. So that's why we have here MN over V ultimate. So what he's telling me that limited to, this is the maximum distance I can use for cutting off at section 6, okay? Because the remaining, which are the red bars at section 5, need to develop LD, right? So they still need to develop LD. So that maximum distance should not be more than Mn over Vn plus D, or the larger of D over 12 dB. Now the 1.3 usually is for simple supports. I will show that in the next slide, because at the supports we have a reaction. So if that reaction is a compressive force, I will introduce compression into the support, then I can use 1.3. If it's going to reduce tension in the support, then I'm going to use 1 without that 30% increase. Regarding this part right here, I will talk about this in the next slide, which is this. So here, if I have a simple beam, then now if this is introducing compression, then I can use 1.3. Again, the total embedment, it cannot be more than this LA. Usually this LA is that length, which is about 150 millimeters, that always extend into the column. So this is not D or 12 dB. The D or 12 dB are only at the inflection point and not at the end of beams. Again, this is the maximum distance that is allowed for me to do that. X7, which is this one here, this is 150 millimeters. This always extend into the next column, at least 1/4 of area of steel, and it is 1/3 for simple span. So for continuous, 1/4 always have to extend in there. If this is compression steel, okay, so if we actually have a doubly reinforced situation occurring here, then I will no longer use the 115 millimeters, and I actually have to calculate the development length for compression. There's like what we call like some quick extensions. So if you do not want to use any of the equations below, so if you have equal spans, nearly equal spans, and if they're uniformly loaded, and you only want to cut not more than half of the steel, then you can use these ratios. You can extend this up to L over 4. Here it's L over 3. Here you leave space of L over 8 and L over 8, and then continue Again, and this is also L2/8, and this is also L2/8, and the rest is continuous. But again, for you to be able to use that, you have to have nearly equal spans, uniformly loaded. In practice, what really happens, again, I'm one of them, many engineers will continue all positive reinforcement into the face of the support that required 150 millimeters, and we extend all negative reinforcement that required distance past the point of inflection rather than using the staggered cutoff points. Now again, that all depends on how big is your project. Are there any real steel savings by doing this? So, I mean, if you have a simple project, not too much steel, I probably will follow these guidelines because again, the more the cutoff, now the constructional cost will increase because you have a construction cost and you have a material cost. So if the construction cost become more than your material cost, then you don't need to do all this. If not, then maybe you should think about it. But again, my job here is just telling you how you can use it if you need to. If you don't, you can follow these guidelines. Again, if you have any questions, and I think you will, feel free to contact me, and you guys have a nice day.